Hi friend, so let's solve from 26th question, the 2018 ECET question paper. So we'll focus on maths part. So this question is related to limits. So if you directly substitute the value of x, it will be 1 cube minus 1 by 1 minus 1, which is in the form of 0 by 0, which is an indeterminate form, and therefore we go with L'Hospital's theorem. So limit x tends to 1. So we will do a derivative of x cube minus 1, and for the denominator, so this is 3x square minus 0 by 1. So if you substitute, it is 3x square, simply substitute x is equal to 1 and you get the limit as 3. So the answer is option number 1. So next you have y is equal to a plus bx by b minus ax. So this is in the form of u by v, and we know the formula of d by dx of u by v is v into u dash minus u into v dash by v square. So here it is, you can write y is equal to b minus ax into d by dx of a plus bx minus a plus bx into d by dx of b minus ax whole divided by denominator square, which is b minus ax whole square. So here we are left with y is equal to b minus ax into derivative of constant is 0, and here you will have b, and you will have a plus bx, and derivative of constant is 0, you will have minus a divided by b minus ax whole square. So this you can write b square minus abx minus minus of minuses plus a square plus abx divided by b minus ax whole square. So these two get cancelled and it will be a square plus b square by b minus ax whole square. So you can simply see it as option number 1. So the next question is related to derivatives. So you have y is equal to x cube into e power x. So if you do a derivative, that is uv, which is u dash into v plus u into v dash, so it is x cube into d by dx of e power x plus e power x into d by dx of x cube, which is nothing but x cube into e power x plus e power x into 3x square. So if you take x square ex e power x common, it will be x plus 3. So this is in third. Now the next question is also related with derivatives. So we have y is equal to secant x plus tan x. So if I take a derivative of d by dx of y, so d by dx of secant x plus tan x, so you will be left with secant x tan x plus d by dx of tan x is secant square x. So if I take secant x common, I will have tan x plus secant x. But if you observe the question, this is y, so I can simply write it as y into secant x. So the answer is second option. Now this is also again with related to derivatives, and it is in the form of u by v. So we'll be writing v into u dash minus u into v dash by v square. So d by dx of y is nothing but 3 plus 2 sin hx into d by dx of 2 plus 3 sin hx minus 2 plus 3 sin hx into d by dx of 3 plus 2 sin hx whole divided by 3 plus 2 sin hx whole square. So this is simply 3 plus 2 sin hx into, if I calculate the derivative of 2 is constant is 0, and I'll be left with sine as derivative is cos hx, and similarly I'll have 2 plus 3 sine hx. The derivative of constant is 0, so I'll be left with 2 into derivative of sine hx is cos hx, and I have 3 plus 2 sine hx whole square. So just by seeing the denominator, this is eliminated, and this is also eliminated. So we have option number 1 and 2, out of which we have to pick it. So I can, if I do the multiplication, I'll be left with 9 cos hx plus 6 sin hx cos hx minus 4 cos hx minus 6 cos hx sin hx divided by denominator square. These two are cancelled, and 9 minus 4 is 5 cos hx divided by 3 plus 2 sin hx whole square. So option number 1 is the answer for this. So the next question is d by dx of y is given as, so whenever you have 1 minus cos x form, you can simply write it as 2 sin square x by 2, and whenever you have 1 plus cos x, you can simply write 2 cos square x by 2. We substitute it, so d by dx of y is equal to, so I have d by dx of square root of 2 sin square x by 2 divided by 2 cos square x by 2. So I'll be left with d by dx of tan x by 2, and this is secant square x by 2, and derivative of x by 2 is 1 by 2. So I'll be having the answer as option number 4. Now here I have two curves, one namely a straight line, the other one is a parabola. So to calculate the value of slope, so I have to take a derivative of this first equation. So dy by dx is equal to 2x plus 3, and the value of it at the particular point 2 comma 3. So if I substitute this, I'll be getting directly 7 as the first slope, and next I have another equation, y square is equal to 2x plus 5. So if I calculate the derivative, 2y into dy by dx is nothing but 2. So I have dy by dx as 1 by y at the point 2 comma 3. So I have m2 as 1 by 3. So we remember angle between two lines, between two curves, is tan theta is equal to m1 minus m2 divided by 1 plus m1 m2. So this is 7 minus 1 by 3 divided plus 7 into 1 by 3. So I will get tan theta is equal to 2. This is the first option. So next I have a function f of x, which is x cube minus 3x square minus 45x plus 2. So whenever there is a question with increasing value of x, this question is related with maxima and minima. So first I will be doing the calculation derivative of this 3x square minus 6x minus 45, and the stationary points can be calculated by equating f dash x is equal to 0. So 3x square minus 6x minus 45. If I apply the root, if we find the roots, we'll be left out with x is equal to minus b plus or minus root over b square minus 4ac by 2a. I'll be having the value of x is equal to as 5 and x is equal to minus 3. So now I'll calculate the value of double derivative of f of x, and I'm left with 6x minus 6. So now I'll be substituting the values, the stationary points in f double dash x, and if f double dash x is negative, that particular value of x is maximum. So f double dash x, if I substitute x is equal to minus 3, I'll be left with f double dash x is equal to minus 6 into minus 3 minus 6, which is minus 24. So the answer for this is minus 3 comma 5. Similarly, for the next question, you are supposed to calculate again the maximum value. So here f of x is 2x cube minus 12x square plus 18x plus 5. So if you calculate the first derivative, you will be left with 6x square minus 24x plus 18. So if you find out the stationary points, so you equate f dash x is equal to 0. So 6x square minus 24x plus 18 is equal to 0. So if I take 6 common, I will be left out x square minus 4x plus 3 is equal to 0. So if I find out the roots alpha and beta of the equation ax square plus bx plus c is equal to 0, the roots are minus b plus or minus root of b square minus 4ac divided by 2a. So I will be left out with x is equal to 3 and x is equal to 1. However, I will find the value of f double dash x to find whether it is the which value of x is related with maxima. So f double dash x is 12x minus 24. If I substitute x is equal to 1, so f double dash x is 12 into 1 minus 24, which is minus 12, which is less than 0. So I have f double dash x as negative. So at x is equal to 1, the value is maximum. So I simply substitute x is equal to 1. So it is 2 minus 12 plus 18 plus 5. So it is 2 plus 6 plus 5. The value of maximum value is 13. So this is simple Euler's formula in which x dou u by dou x plus y dou u by dou y is equal to n into u. So this is related with partial differentiation. Now this question is related with integration. So if you substitute root x is equal to t, so we'll be having 1 by 2 root x dx is equal to dt. So if I substitute it, simply I left with cos t and 1 by 2 into, so this part is dt. Or I can simply substitute this, send this to this side. So I'll have 2 outside. So this is 2 sin t plus c. Now 2 sin t is root x plus c. So in this case the answer is 2 into sin root x plus c. Now this is also a basic formula in which you have to remember for ECET. So integral root over a square minus x square is sin inverse x by a. Now let's get back to another question which is also related to integration. So observe this is in the form of 1 by a square plus x square. You have to reduce it to this form. So I'll make sure I'll convert this into 2x plus 1 whole square. So 2x plus 1 whole square is 4x square plus 4x plus 1, and I'll be left with another 16, which is 4 square. So if I take this as k, so 2x plus or t, 2x plus is equal to t. So dx, 2 into dx is equal to dt. So I will simply substitute it. So I'll be left with 1 by t square plus 4 into dx is dt by 2. So I'll have dt by 2. So 1 by 2 into integral of 1 by x square plus a square is equal to 1 by a into tan inverse x by a. If I use that particular thing, I'll be left with 1 by 4 into tan inverse t by a. A value is 4. So if I substitute t as this, I'll be left with 1 by 2 into 1 by 4 into tan inverse 2x plus 1 divided by 4. This is your option number we have integral log x dx. So here, so this is in the form of integral uv, which is u into integral v minus integral u dash into integral v. So here, so I have integral log x, I can write it as log x into integral 1 dx minus integral 1 by, so I have to calculate the derivative of log x, which is this, and I have integral 1 dx. So this is nothing but log x into x minus integral 1 by x into x dx. So this is log x into x minus x. If I take x common, it will be x log x minus 1. So if I see my options, third option satisfies the thing. So here I have integral with definite integration. So x power 1 by 2 plus 1 by x power 1 by 2 dx. Well, first do the calculation with this. So integral x power n is equal to x power n plus 1 divided by n plus 1. So here I have integral x power 1 by plus 1 by 2 x power minus 1 by 2 dx. So this is x power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus x power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. So this is nothing but, so I'll be having x power 1 by 2 plus 1. 1 by 2 plus 1 is nothing but 3 by 2. So this I can write simply as x power 3 by 2 divided by 3 by 2 plus x power 1 by 2 divided by 1 by 2. So if I substitute the limits, so I have x power 3 by 2 by 3 by 2 plus x power 1 by 2 divided by 1 by 2 at 4 and 1. I'll be left with 4 power 3 by 2 by 3 by 2 plus 4 power 1 by 2 by 1 by 2 minus 1 by 3 by 2. 1 power 3 by 2 is nothing but 1 plus 1 power 1 by 2 divided by 1 by 2. So I can write 4 as 2 square, and 4 power 3 by 2 will be 2 power 3 by 2 into 2. So 2 cube will be 8. So this is 8 into 2 by 3 plus 2 into 4 power 1 by 2 is 2. From this you will be subtracting 2 by 3 plus 2. So this is 16 by 3 minus 2 by 3 plus 4 minus 2. So this is 14 by 3 plus 2. So this is 20 by 3. So here you have integral of 0 to pi by 2 into sine square x. So here you have to remember, you can write sine square x as 1 minus cos 2x by 2. If you substitute it, integral 0 to pi by 2, 1 minus cos 2x by 2 dx. So it is again 1 by 2 integral 1 by 2 into 0 to pi by 2 minus integral 1 by 2 common if I take it dx my cos 2x dx. So this will be 1 by 2 into pi by 2 minus 0 minus, so integral of cos 2x is 1 by 2 into sine 2x by 2 at pi by 2 and 0. So we have sine 180 as 0 and sine 0 is 0. So this integral is 0 and we'll be left with pi by 4. So the next question is y square is equal to 4ax. So when you have a parabola and a straight line, the area enclosed y square is equal to 4ax and x is equal to y is equal to mx plus c. The answer is 8a square by 3m cube. Now here x is equal to 2y or y is equal to 1 by 2 into x. So here m value is 1 by 2 and you have y square is equal to 4ax, or I can simply see the value of a is equal to 1. So the answer will be 8 into 1 square divided by 3 into 1 by 2 whole cube, which is 8 into 2 cube. So 8 into 8 divided by 3 is 64 by 3. So if you see the options, you will be left with this. So this question is a tough question. The student has to remember this question is related to both limits and integration. So if I take n common, I have a series n plus 1, n plus 2 and so on. So I have to write it in the form of summation limit n tends to infinity, and I can start my n is equal to 1, 2. So if you see 1, 2, 3 so on till n, and I can write it in the form of 1 by n plus r, because the value of r is ranging from 1 and it is ending till n. So now if I take 1 by n common, so limit n tends to infinity. So if I take 1 by n, summation of r is equal to 1 to n, I'll be left with 1 by 1 plus r by n. So as n tends to infinity, 1 by n tends to, if you consider r by n is equal to x, now 1 by n will be your dx, and you can simply write the limits as the integration limits 1 to integral. So here the integral limits will be from 0 to 1, and it will be in the form 1 by 1 plus x into dx. So this is nothing but integral 1 by 1 plus x is log mod 1 plus x with limits 1 and 0. If you substitute x value is equal to log of 1 plus x with 1 and 0, it is log 2 minus log 1, and this value is 0. So I have simply the value of x as log 2. So now let's get back to question number 44, in which we have the equation ay square is equal to x cube. So if I do a derivative, so I'll be left with a into 2y into dy by dx is equal to 3x square, or I have a is equal to 3x square by 2y into dy by dx. So if I substitute this a in this equation, I'll be left with 3x square by 2y into dy by dx is equal to into y square is equal to x cube. So this I'll be having by doing the, so I'll be left with 3y by 2x is equal to dy by dx. So This is the solution. Now, this question is also used for differential equations. So I'll just move this into the other side. So minus 1 by x square into dy. So if I rearrange the terms, it will be 1 by root over 1 minus x square dx is equal to minus integral 1 by root over 1 minus y square dy. And if I apply integration formulas, I will be left with sin inverse x is equal to minus sin inverse y plus c. And if I move this to this side, I will be left with sin inverse x plus sin inverse y is equal to c. So option number 4 is the answer. Now this question is also similar form. So this I will just move it into 4x plus y plus 1 whole square is equal to dx. So if you observe the question, so in this case, so let 4x plus y plus 1 is equal to v. So and if you do derivative on both sides, we will be left with 4 plus dy by dx plus 0 is equal to dv by dx. So I have simply dy by dx is dv by dx minus 4. So here I will be left with dv by dx minus 4 is equal to v square, and I can simply write dv by dx is equal to v square plus 4, or I can write dv by v square plus 4 is equal to dx. Or this is simplified after integration on both sides. I will be left with 1 by a into tan inverse x by a, or 1 by a into tan inverse v by a is equal to x. So 1 by 2 into, here a is, this is a square, so a is 2 into tan inverse 4x plus y plus 1 divided by 2 is equal to x. So the answer here is 1 by 2 into tan inverse, option A. So the next question is again related to differential equations. So I have 2xy dx plus x square dy is equal to 0. So if I send this to the other side, RHS, so I have 2xy dx is equal to minus x square dy, and if I divide both sides with x square, so I will be left with 2x by x square is equal to minus dy. So I will be having 2 by x dx is equal to minus 1 by y dy. So if I apply integral to both sides, integral 2 by x dx is equal to integral 1 by y dy, I will be left with 2 log x is equal to minus log y plus log c. So I will be having log x square plus log y is equal to log c, or x square log of x square y equal to log c, or x square y is equal to c. So the answer is option number 2. Now, so here if you compare it with the equation, original differential equation, you will have p as 1 and q as e power minus x. So this is q and 1 is your p. So integrating factor is e power integral p dx. Here integral e power 1 dx, which is e power x. So I multiply. So the general solution is simply y into integrating factor is equal to integral q into I integrating factor dx plus c. So y into e power x is equal to integral e power minus x into e power x dx plus c. These two get cancelled. I will be having y e power x is equal to integral 1 dx, which is y e power x equal to x plus c. So the equation is something in this form. The next question is also related with differential equations. So this is the particular integral will be in the form of 1 by d square plus 5d plus 6 of e power x. Now I substitute e power ax, so a is equal to 1. I will directly substitute the value of a in this particular equation. 1 by 1 square plus 5 into 1 plus 6 e power x. So I will get e power x by 12 as the particular integral. So the next question is the last question of this exam. So I'll have this particular equation. I'm supposed to solve the roots m square plus 3m plus 2. So this is a quadratic equation, and I can write it in the form of m plus 1 into m plus 2. So my roots are m1 is equal to minus 1, m2 is equal to minus 2. So my CF is c1 into e power m1x plus c2 into e power minus m2x. Plus. So CF will be c into e power minus x plus c1 c2 into e power minus 2x. My answer is option number 1. So this is the end of 2018 questions of maths, and I have left only 3 questions as homework, which is question number 13, question number 25 and question number 46, which I will solve in the next class.